This video is looking at gauge R&R studies, and it's a pretty common thing that people use in quality in order to determine if your measuring device or your methods of measuring things within quality are precise enough. So in this kind of analysis, what we do is we check the measurement device to see if it is appropriate for the situation. So when we look at the variability in any measurement, some of the variability associates with the variability of the part, and some of it will be associated with the variability of the measurement. And that's what's called, in this case, the measurement error, or the variability of the gauge. Now, when I talk about variability, I'm talking about, in the case of sigma squared, it's the variance, but another really kind of interchangeable way of looking at it is a standard deviation. But variances, you're able to add them, so we often talk about variance when we're talking about additive variabilities. Okay, so the first thing said is the measurement error. So this is not the variability associated with the part, it's actually the variability associated with your measuring. So the one way you could do this, if you measure a part over and over and over again, you know the part is the same length, the same dimension that you're measuring. Any variability associated with the numbers that you're getting out of the measurements are associated with the measurement error, because you know the part isn't changing because you're measuring the same part over and over again. So this isolating this part of it that's called measurement error. And in gauge R&R studies, what we do is we look at sort of the real error associated with noise and randomness of the system or of the device that you're measuring with, and then also the variability associated with the operator who's using it, because usually a person is doing the measurements and there's variability associated with them. So we try to break out the repeatability, which just has to be the inherentness of the measuring device, and the reproducibility, which is the measurement error associated with the person who's using it. Now the way we do that is we actually measure a bunch of different parts, and we measure them, we have different people measure them. So we can then isolate, we can do a ANOVA study to isolate where the errors are coming from. So this is a printout from an ANOVA study where we had 10 different parts, and we had 3 different operators using measuring parts, and we had 10 different parts. And so what we did is we ran an ANOVA to see if we could explain the variance in the numbers. Now what you want to look at down here is the variance in the part. So the part itself has some variability, which is fine. I mean, we know there's going to be variability in the part. But you can also see that there's some variability associated with the operator, and then there's an interaction of the operator and the part. So both of these together are attributed to the operator, and then this is just the general error associated with the measurement device. So these two are the variability due to the operator, and this is due to just the error. So when we look at those together, we can see that, if you remember, this is 0.56 and 0.71 is the operator, these numbers. So this is just, these two are for the operator, and this is just the error associated with the measurement device. So those all together are going to be the gauge, both reproducibility and repeatability. And so if we can do this, calculate this precision to tolerance ratio, and the precision to tolerance ratio, we want it to be the point less than 10%. And the way we do that then is we take the 6 times the standard deviation of the gauge. So this is the variance of the gauge. We take a square root of that and get 1.34 times 6, and then the difference between the upper and lower tolerances we take here, and we can see that this is more than 10% of this ratio is more than 0.1. So we are saying this is not considered a very capable measurement device. And that's the kinds of things we're going to do with gauge R&Rs. We actually try to isolate the variability associated with the measurement device as opposed to associated with the part itself.